Hello student, very good morning to all of you. Do you remember what were we discussing yesterday? I think we were discussing about diazocoupling reaction. What is diazocoupling reaction? What type of the substituent and the reagent coupled together and the resulting product is obtained. What are the application of that diazocoupling reaction that we have seen in our previous lecture. So today what we are going to learn, actually look at the blackboard here. What is written? Ipso substituent. I think this word you as far as I am concerned, you never heard this word before. I think as far as the T.Y.B.Sc B.Sc students are considered. So this ipso, what does it mean? And this ipso concept, the ipso substituent we know that, but that what does it mean? Ipso means what? Here remember we have seen the the aromatic compound undergoes electrophilic substitution reaction more easily, or we can call it as a readily, and to get ortho, meta and para product, right? And if the monosubstituted aromatic compound, specifically as a monosubstituted benzene, and as we know that, let us consider here, I am trying to explain that ipso concept here. So remember here, as we know that this is a benzene ring and that benzene gets substituted by any substituent. Suppose this is a substituent, we don't know the nature of that substituent, but if a monosubstituted benzene is there, monosubstituted benzene, this one, right? Monosubstituted benzene, and in monosubstituted benzene, when we are adding electrophile, right? This when we are adding electrophile, the resulting compound formed like this, right? Now here, look at here, Y is as it is, electrophile attacking at this position. In the second case, what is happening? This is the Y, the electrophile attack at meta position, and then the next one, what is happening here? This Y substituent as it is, but the electrophile which is attack at meta position. So this is the ortho product, right? This is the ortho product. This one we can call it as a meta product, and this one we can call it as a para product. These are the substituent when Y get Y we know that we don't know here the nature of that Y, but as far as whatever reaction we have learned regarding as aromatic compound, the aromatic compound monosubstituted benzene when undergoes as a electrophilic substitution reaction more readily or more easily. Why? Because that benzene itself is a nucleophilic in nature, but depending upon the nature of the Y. Suppose the Y, nature of that Y is a electron donating group. Electron donating group, it gives ortho and the para product, means they are the ortho para director, as we know that. If Y is a electron withdrawing group present, the nature of that Y, suppose if you consider here, is the electron withdrawing, it gives a meta product, means the electron withdrawing group means monosubstituted benzene, they are the meta director, means but that electron withdrawing group deactivate the benzene group, means that type of the those are withdrawing electron from the benzene ring, that type of the group are called as a deactivator. Deactivator means they decrease the reactivity of the benzene ring, and those are the electron donating group, they providing the electron to the benzene ring. Benzene already is a nucleophilic in nature, the reactivity of that compound is goes on increasing, and therefore, but as we know that there are the three orientation or three positions two are identical position adjacent to electron substituent group, they are known as a ortho position, and therefore they are get more activated when the electron donating groups are present, as well as they are again as compared to as a meta at a, if you we already seen as a resonating structure by looking, by observing the resonating structure, there you will find at ortho and the para position there will be a negative charge, and therefore they are more active positions are, and therefore the electrophile, as we know that it is a electron deficient in nature, and therefore the resulting compound are obtained as a ortho-para director, and when the electron withdrawing group and it deactivate ortho and para position, the position remains there for attack of electrophile is possibly that attack at meta position, and we are getting such type of the broader product. Then ortho, meta and para, they are known as electrophilic substitution reaction, when that means this group is a directing group, it direct giving a direction to the electrophile where it should attack. So depending upon that we are getting this type of ortho, meta and para product. Understood this one? And now when that let us see this monosubstituted benzene, when it is treated with that electrophile, look at here carefully, listen carefully here, what is going to happen, that what we can call it, this Y group, this Y group get replaced by this one electrophile. This one means this group, whatever group present on that monosubstituted benzene, it get replaced by that electrophile, and this type of the substituent is known as ipso substituent. Understood this one? Ipso substituent means what? Whatever group present on the benzene ring, that group itself get replaced by, get substituted by the electrophile, and that type of the substitution is called as a ipso substituent. One more question may appear in exam. Remember, what do you mean by the ipso substituent? Remember, ipso substituent is nothing but the whatever group present in a mono or maybe as other, means that whatever electrophile we are adding, whatever the substituent present on the benzene, that get substituted by the electrophile, means the whatever substituent present on that benzene ring, on the same carbon atom, the substituent is attached by replacing that group, whatever original group present on it. So that type of the substituent is called as a ipso substituent. Understood this ipso substituent? Now let me so this is known as a ipso substituent. Now let us look at as a mechanism of the ipso substituent. Just now we have seen how that what do you mean by the ipso substituent? Means here let us see the mechanism of that ipso substituent. Let us see here, as we know that here this is a Y group, right? This is a Y group. When we are adding, this is a irreversible reversible reaction. Here we are adding as a electrophile, and then we are getting here such type of the what we can call it as a, here electrophile is attack at this position, and therefore what is going to happen over there, this type of the electrophile when attack at this position, the positive charge comes over there, and now here we can show this one the Y group or electrophile or stereochemistry we can show over here. So their Y group may present over there, and from that the electrophile is attacking, and we are getting as a such type of the intermediate over here. And when that Y group that is removed from it, then again the substituent means the product we are getting here, this type of the product, this is known as a ipso substituent or ipso reaction. So this is a simplest mechanism of that ipso substituent. Remember, what do you mean by the ipso substituent? Means what? Whatever original compound in a monosubstituted benzene, that group itself get replaced by electrophile. So that type of the substituent is called as a ipso substituent. And there are a number of reactions, such a type of the reactions present in an organic compound. Let us see some of the reaction. Here we are going to talk about the ipso substituent reaction. Now let us see here the reaction is known as a proto-desulfonation. It is known as a proto-desulfonation. Proto-desulfonation. What does it mean? Proto-desulfonation, as we know that in the sulfonation reaction, when benzene treated with fuming H2SO4 or concentrated H2SO4, then what you are getting, there you are getting as a benzene sulfonic acid, if you remember that one. And that proto-desulfonation means what? And that benzene, as we know that this is a benzene, and where the sulfur, this is SO3H, this is known as a benzene sulfonic acid. This is known as a benzene sulfonic acid. Here I am writing benzene sulfonic acid. Benzene, let me write here, benzene sulfonic acid. This is a benzene sulfonic acid. When this is treated with H+, H+ is a electrophile, and in a workup means water is using there. What do you get? There is strongly heating, you are going to get over here, this is a benzene and plus H2SO4, that is the product form over there. So this type of the reaction is called as a proto-desulfonation. Proto means what? Hydrogen electrophile is directly attaching here and replacing that SO3, and desulfonation means D means remove, sulfonation means sulfur group from this benzene nucleus. So that type of the reaction is known as a proto-desulfonation reaction, and this benzene we can obtain just by treating this in presence of the concentrated H2SO4 heated, and you will get as a back benzene, and the H2SO4 is retained over there. Then next one is a proton. Then next one may be as a proto-dealkylation. Suppose we have a acylation, proto-deacylation. So that type of the reaction is occur here, proto-deacylation. Let us see. Second one is a second reaction is a proto-deacylation. Proto-deacylation. So this type of the reaction again occur over there. Now let us look at as a starting compound is this one. I am writing over here. Here is a compound Me3, that is a silyl compound over there, and here at ortho position is a hydroxy group. when this compound is heated with H plus, or what we can call it as in case of that HClO3, triple chloric acid, that is used as an acid over there, or that is the source of H plus, and you are going to get over here what this is, and you will get over here is a phenol, OH. OH we are going to get over here is a phenol. So this type of the reaction is known as a proto-decellulation. Then proto-decellulation, after that there will be a nitro-dealkylation. Then third reaction taking place over here, that is the third example. Which one is third one is known as a nitro-dealkylation. Nitro-dealkylation reaction. Here we have taken the starting compound is this one, then CH-Me2, CH-Me2, and at CH-Me2 here again. CH means cumene type of the compound, Me2, and that will be treated with HNO3 in presence of H2SO4. That is a nitrating mixture. HNO3 in presence of H2SO4. This is the reagent nitrating mixture, as we know that when it is treated with such type of the compound, one of the group get replaced by the nitro group, so that we will get as this type of the compound. Here nitro group NO2 means this group get replaced by the nitronium ion, and other thing remains as it is. Me2, Me means methyl group, Me2, it remains as it is. So this is the reaction taking place over there. Then nitro-debromination. Let us see the fourth reaction, nitro-debromination. Fourth reaction, nitro-debromination. Nitro-debromination means what? Here the starting compound is taken here. D means remove, bromine. So bromine atom must be there, and then on the other side there will be a methoxy group here, OMe, and this compound starting material is treated with HNO2 in presence of, that is the nitrous acid, HNO2 in presence of acetic anhydride. And as we know that AC2O is nothing but we can write here acetic acid CH3, C double bond OO, C double bond O, and CH3. Means this group we are knowing as a AC and 2, and that's why we can write as a acetic anhydride. Name of this compound is acetic anhydride. So this one is nothing but as acetic anhydride, and what is going to happen there? The nitro group is comes over there. So nitro anisole you are going to get over here. Here is a NO2 group comes there. Debromination is bromine get replaced by the nitro group over there, OMe. So these are the general reaction we are talking over there. So this is again bromo desulfonation, that is also as one of the reaction may take place over there. Let us see here another one. Fifth reaction is this one. Fifth reaction is bromo desulfonation. Bromo desulfonation. Bromo desulfonation. Again starting compound having this one SO3H and methoxy group at the para position. OMe is nothing but as Me means methyl group. Me is nothing but as this group and is known as a methyl, right? And therefore sometime it is written as a Me, methyl. And when this compound is treated with bromine, and it gives or produce this type of the product. Here Br is coming, that is a bromo desulfonation. Desulfonation means removal of that sulfonic group, and we are getting as this type of the product OCS3. So all these reaction are the what we can call it as a bromo desulfonation reaction we are talking about. And now the one more reaction is there, that is hydro dealkylation. And 6 reaction maybe as a dealkylation, hydro dealkylation reaction. Hydro dealkylation reaction. Hydro dealkylation reaction. Now when we have this type of the compound benzene, and here C again is a CH3 thrice time, means here the tertiary group present, tertiary butyl benzene, and when it is treated with very concentrated H2SO4, this is nothing but as a ipso substituent. Takes place, and we are going to get the product over here. What is happening? This is attacking at this position, and so that we are getting over here this one hydrogen atom over there, and C, then CH3 thrice time, right? This is a bracket, 3 methyl group attached to over there, and here you can show this one positive charge over there. And now what is happening there? This is breaking, no, not like this. So it is a breaking like this, and aromatization back over there, and we are going to get the here this one benzene like this, and plus here the electron, this CH3 thrice time positive charge. As we know that the nature of that carbocation, what type of the carbocation it is a tertiary carbocation, right? Tertiary carbocation, you can write this compound for sake of convenience, CS3 here, CS3, and the another CS3 over there, and this is a positive charge, means it is a tertiary carbocation, and therefore it is a very, very stable, and that's why this type of the hydro dealkylation is occur in such reaction. And then in some other cases also the reactions are occur. For example, in suppose we have some rearrangement of alkyl benzene to ipso fusion, there isomer also involve ipso attack. How this ipso attack is taking place? Let us see the last example of this ipso. Now how the rearrangement occur over there. Now let us see how the rearrangements occur in this particular ipso substituent. Suppose you have this compound, this is a orthoxylene, here CS3 and this CS3, and you may get this type of the compound over there, here CS3 and the CS3 methyl group over there. How it is possible? If there is a rearrangement reactions are taking place, and then we will get as a this. Now let us see how this takes place over there. Now we have this one orthoxylene CS3 and this CH3, both the methyl group present ortho to each other. So that type of the compound is called as orthoxylene. This is the common name of this compound. And now when it is treated with H plus at an equilibrium, what you are going to get? You will get over here this one. This double bond remains as it is here. CH3 hydrogen atom over there. Or you can show here hydrogen, one hydrogen atom, another methyl group, and positive charge we can show over here. And now the double bond we can put it this side. So there is a positive charge when hydrogen atom is attached. We are getting as this type of the compound. Then rearrangement reaction takes place. Rearrangement reaction takes place. And we are getting here this type of this methyl group shifted from here to here. You may get this one CH3, this double bond as it is, then one methyl group here, and here H, the positive charge. And now by losing the H plus here, minus H plus, this one, get aromatization, and we will get the desired product, that is a metaxylene here. CH3 and CH3, this double bond, this is a metaxylene we will get. So I think with this we have completed what do you mean by the ipso substituent. The main point or the key point you should remember as per as exam point of view is concerned. What is ipso substituent? Ipso substituent means what? Monosubstituted benzene, whatever group present on that benzene, that itself get replaced by that electrophile. Such a type of the substituent is known as a ipso substituent. I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.